Have you ever thought of the amount of information circulating in the internet in just 1 minute? Over 640,000 gigabytes of global IP data is transferred. Whereas only 2 years ago, the number of networked devices was as large as the global population, this number is expected to double by the end of 2015. Therefore, there is an urgent need for storage, switching and transmission systems with ever higher capacity and more flexible management of data and data flows. Data centers, enormous stock rooms that store and manage most of global data, communicate with each other and interface with the internet using gateways that are based on 40 and 100 gigabit Ethernet interfaces. Panther targets to magnify the capacity of these interfaces to the mythical 1 terabit per second by developing a new generation of optical transmitters and receivers in the external side of these gateways. However, scaling capacity is not the only requirement for high-performance inter-data center connectivity. Flexibility and management of the corresponding data flows is an equally crucial feature. While so far flexibility is characterized as 3M, relying on the adaptation of the bit rate, the modulation format, and the transmission reach, Panther introduces for the first time the much-needed multi-flow function to terabit transceivers. Multi-flow is a type of operation that evolves the current point-to-point optical connectivity to the more advanced point-to-multipoint. Thus, depending on the traffic that should exit the data center, the capacity of each optical transceiver can be either concentrated into one optical flow, enabling faster transmission to a single destination, or distribute it into a larger number of optical flows, enabling simultaneous transmission of data to numerous destinations. Perfecting the 3M description with a 4th M, Panther offers an unparalleled perspective of flexibility. Whereas previous efforts have been hindered by limitations regarding the available material systems, Panther innovates firstly by investing on passive polymers for the development of optical motherboards, and secondly by employing the most promising technologies for the development of the optical and electrical add-ons, which can support high-speed operation at symbol rates up to 64 gigabaud. These technologies include the electro-optic polymers for arrays of high-speed modulators, the indium phosphide technology for arrays of high-speed photodetectors, and the indium phosphide double heterojunction bipolar transistor technology for arrays of high-speed electronics, both at the transmitter and the receiver side. By the end of 2016, Panther aims to develop a final transceiver module with a total capacity of more than 1 terabit per second, with the ability to aggregate or distribute this capacity in just 1, 2, 3, or 4 independent optical flows. This impressive performance will come with a potential reduction of 55% in power consumption per bit and more than 60% in cost per bit, with multiple benefits stemming from the material system, the integration concept, the operation at high baud rates, and finally, the more efficient use of network resources due to the multi-flow operation. By developing this cutting-edge integration platform, Panther places Europe at the forefront of photonic integration technologies for datacom and telecom applications, and ultimately delivers the most exceptional internet experience to the end user. In order to achieve these goals, Panther has set up a consortium consisting of 8 partners from Greece, France, Germany, Italy, Switzerland, and Denmark. For more information, please visit the Panther website at www.ict-panther.eu.